Very happy to be here today. I guess as I could not understand, I'm Jan Kameny from the CTO of the Definity Foundation. The Definity Foundation is probably the largest R&D operation in the blockchain space and a major contributor to the Internet Computer Protocol. And today I want to explain to you or give you an update on the Internet Computer Protocol and how it relates to DPIN. I would say that the network is actually one of the largest DPIN networks on the world, for more the traditional backend, maybe if you want to see that. So before going there, let us take a step back and think about why are we caring about decentralization? Why? I guess it's not like tokens and meme coins and all of that. It's really. Does this work? How can I change the slides here? Here we are. So why decentralization? Right. Why do we care about that? Again, it's not about meme coin. It's really about. Do I press here? There we go. So it's really about security in some sense, or no single point of failure. How can we build a resilient system? How can we build a secure system? If we just have a system that's based on one computer, the computer might fail, the computer might get hacked. So really what we're interested in here is to build a system that has no single point of failure. So we want to sort of secure the world with a cooperation around the world from a cryptographic protocol. That's the goal here. That's why we care about decentralization. And the proof here is also that the Bitcoin network is a very great example of that. It is out there since quite some years now. It has never been hacked. So it's the best proof that we can build a secure, unhackable, relying system that actually provides true utility. The drawback, of course, of Bitcoin is that it is very expensive, it is slow, it's not very effective. So how can we do that? And at the Definity Foundation, we set out to do that. We built the Internet Computer Network. And the Internet Computer Network is created by a protocol, just like the Bitcoin network, but it has very different design. So we designed the protocol bottom up from different principles, right? Just thinking about how can we build a distributed, decentralized computer bottom up. So the idea here is that the network is formed by different node providers. Those are hardware, designated hardware, quite similar to Bitcoin, but just not hardware that are designated to solve proof of work, hash inversions, but rather sovereign hardware that is top-notch, high-end server machines in data centers, and the protocol groups those server machines into blockchain subnets. So those blockchain subnets can combine different nodes of different characteristics. They can be, maybe subnets that have GPUs in them that can support AI. They can be different locations, different jurisdictions. So we have a subnet that is only in Europe. We have some that is in other locations. We even have a Swiss-only subnet. So depending on your requirements, you can host your smart contracts on these different subnets. And here we go. Next slide again. So what these subnets can do, they run smart contracts. And now these smart contracts are really just a piece of software, very different from normal smart contracts in the sense that they have, they can store 400 gigabytes of data in a smart contract. Essentially, they run natively on those server machines, as WASM modules, as fast as they could run normally on a server machine. So that's how fast the Internet Computer Protocol allows you to process smart contracts as opposed to the Bitcoin network. So really, you have to think about this as more like a cloud provided by crypto software rather than a blockchain protocol. But at the end of the day, this is a blockchain protocol. And by combining these different subnets, you can, at the end of the day, get like what we call an internet computer. So the software runs in the internet. You don't have to worry about that. Just very much as a cloud, but as a decentralized, distributed system. And so as a canister smart contract, what you do, and this is really here why this is DeepIn, you rent resources provided by the network. So you rent compute capacity, you rent storage capacity, you rent communication. And actually here this communication is like you can communicate as a smart contract with like any Web 2 servers on there, also with either on any other blockchain. So it's really very much more like a cloud solution here rather than like a traditional blockchain where it just runs in an isolated mode and cannot talk to the rest of the world. Of course, smart contracts also can call to each other, so you can build actually with these smart contracts something like a chat service, and that actually exists on the internet computer. You can have like WhatsApp services that are even then owned by the community. And so that's really the interesting part here, that these smart contracts are an extension of the protocol, right? It's if we have like a protocol that builds the secure system, now smart contracts extend that protocol into the application space, and from that inherit the same kind of security properties. So they are tamper-proof, unhackable, unstoppable, just like the basic network itself. Of course, they also can do tokenization because they can now have managed digital assets on top of the blockchain. That also means with these tokens, they can be controlled by a DAO, a decentralized anonymous organizations. And actually, that can happen end-to-end onto the protocol. So like there's the chat application that I mentioned actually is owned by a DAO. So it's owned by the community itself. And that community can then decide whether or not to upgrade its software, to upgrade the new version, or also not to do it, right? So it's like decentralized end-to-end. So you really can build almost anything with that. In the particular, also you can add to the DeepIn infrastructure here. So let's go a bit into that. So with the DeepIn infrastructure, as we just heard in the previous talks, there's a ton of devices out there that collect the data, that sensors, that measure things, access to wireless and whatnot. And you want to manage those things in a decentralized fashion. Well, you better have like a backend that allows to do it. And so that means that these devices want to be managed. So who should be part of the network, and also they want to send tons of data to the backend. Now that means we need to have a backend just like the internet computer, where that is possible. So like that means a smart contract can manage all those devices. On the other hand, of course, users want to make use of that, also connect to that DeepIn network of sensors. And also here, the internet computer actually provides that, because like every smart contract is accessible from a user's browser just with a URL, and that's all that a user needs. The user doesn't need any tokens or whatsoever. Just get up their mobile phones, enter like a URL, and they're connected to that. And that also means they have access to the data. They can manage DeepIn devices and profit from all the services from the DeepIn. Again, that's. If you think about the blockchain, that's normally what would come to mind, but that's why the internet computer is so much different, because it actually provides these capabilities and can really help the DeepIn space here by providing that back end and front end to manage and interact with DeepIn devices. Yes, so I hope this was like motivation to you to check out the internet computer, come and build your DeepIn system, manage DeepIn devices. Here's a link to the website, and I'll be still around if you have questions, and happy to discuss. Thank you so much.